about the sun. So here is, where am I looking for? Um, I'm going to show you just here's a demonstration about how the sun sets, and then I'll show you what the sun looks like. So this line, we're viewing it from a elevated point of view, from a celestial point of view. So if this was the sun and it's moving across this line, it's going in a straight level line. You agree this line is level?
Yep.
It is.
Yep.
Okay. And so this could be clouds, a cloud deck, it could be mountains, it could be a city skyline, and it never went below this. Now I have a camera on the table, on the counter, on the other end watching it. We're watching the same thing. And if I showed you this first, I would say, is this line level? And you'd be like, no, it's angled down like at 45 degrees. And I'd say, are we going below this thing that appears to be at eye level, but it's not? It's really above eye level. And it just goes beyond it. Now look at this line. This is a level line, but this is how perspective works. And most people don't understand perspective. Now let's compare this to a real sunset. So here's my sun just going away across a level line. Here's the sun going away. What's it going behind? This is called the atmospheric deck of opacity. And if I zoomed out on that, it would look like it's going below the horizon, but it's not, okay? So that's viewed from a terrestrial point of view, okay? So let me show you what happens under certain conditions, right? This is on a super cold day, over land, no humidity, and the most clear sky ever. The sun was up here and it went down, 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 down. Now, if the earth was spinning, it would just keep on going, but it didn't. It went down, 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 and it stopped right here. Now, this is super sped up. It just sat there. Now, my friends are at the beach over here. It's already dark. They already saw the sunset, but this is just the sun going away through the soup of the atmosphere and taking its light with it. Now, you've never seen that because you never had those conditions to see it. You've seen sunsets over the ocean, and you think they're going below the physical curve of a ball, but we can prove that that's not the case at all. If you're a 6-foot tall person at the edge of calm water, when you see the sunset, it should set 3 miles away from you because there's a 6-foot drop at 3 miles, according to the globe math, right? But you see it set way farther. So we can see too far, right? If we live on a ball of 24,901 miles around, there's a physical curvature. At 3 miles, you shouldn't be able to see the surface of the water anymore because it's below the curve if you're 6 feet tall. If you're lower, it's even closer. If you're a foot off the ground, it's only 1.22 miles away. But we can get a camera and zoom on things 10, 15, 20 miles away and still see them, right? For example, this is a spot in Aluja, France. And from this viewing spot, Mount Canigou is out here 175 miles away. Well, according to the globe math, using the globe curve calculator, the top of that mountain should be over a half a mile below the curve, right? Well, we don't see it. Interesting, okay? The light from the mountain isn't bright enough to push to 175 miles of atmosphere. Just like if you're in a big pool, you can't see the far side of the pool just because the water becomes opaque. Air does the same thing over a greater distance. But twice a year, the sun migrates in between the two tropics. I'll show you that in a moment. When it lines up with that viewing spot, the sun's light is powerful enough to push that far, and it backlights the mountain. And here is the entire mountain, okay? The top of this mountain should be a half a mile below a physical curve, but it's not. It's right there, okay? This is just one of many proofs, And the other one they indoctrinate us with is they say boats over the horizon. We've seen boats disappear from the bottom up. Yes, if the earth was a globe, boats would disappear from the bottom up. But there's another reason they disappear from the bottom up. Out here, you don't see anything, but as we zoom in, we're zooming in and we're increasing the angular size. And as we increase the angular size, look, we can resolve that there is a boat there. Our eyes can only see a certain size. And as we zoom out, these little waves in the foreground are bigger than the boat, and they're going to block the boat, okay? Just like my fingers blocking the boat, right? Right? And the boat disappears. Now, it's not going over the curve, although a glober standing on the beach goes over the curve. But it's right there. I zoomed in. I just proved it's not. My finger can't hide my face unless I went like that, and then it could hide my face. So a tiny wave, whoops, went on here. A tiny wave can hide an entire city skyline. All right. So the argument is, well, that boat, we don't know how far it is. Well, we know how far this is. This is an oil rig. It doesn't move. 9.4 miles away. The camera is 1 foot off the ground. The waters should disappear behind the horizon at 1.2 miles away. Let's round up, say 2 miles. Give the globe a little advantage. Not only can we see this entire thing, we can see the surface of the water for miles beyond it. Okay. We have some video of a boat that we know how far it is, and we see another boat miles beyond it, so higher on the horizon, and it's way beyond this boat. And we said, okay, what if that other boat was only 1 mile behind it? So it was to be 17 miles away, I think is the number. And we did the curve calculator. The radius of the Earth would need to be, I think, 380,000 miles. 380,000 miles, when they tell us the radius of the Earth is like 39,000 miles, just under 4,000 miles. So it would have to be the world would have to be 100 times bigger than they tell us to see that boat.